Right, in this video, we're going to talk about net ionic equations. So we're going to, which are nothing more than our double replacement reactions. Okay, so we're going to start there, review our double replacement reactions, and identify our precipitates like we've done previously. Okay, so sodium chloride, right? Sodium's in group 1, so it's +1. Chloride is -1, so that is NaCl. That's going to react with silver nitrate. Silver, of course, is always +1, and nitrate is -1. So we have silver nitrate. And then in a double replacement reaction, the two ions trade places. So sodium and silver are going to trade partners. So you get sodium combining with nitrate. We have to use the charges to combine them correctly, but since they're both 1, it's just 1 of each. And then our silver chloride. And again, we have to use our charges, but again, they're both 1s. And so that's the correct formula because it already adds to 0. And then, of course, you have to make sure it's balanced. In this case, since everything was 1, it ends up balanced. Okay. Now, if we talk about our net ionic equation, if we look at our simulation we were using, right? So if we look at the simulation, we have the sodium and the chloride ions are separating, right? And the silver ions and the nitrate ions are separating. But as you see, the silver ions interact with the nitrate ions. They stick together and they form, the silver ions and the chloride ions, they stick together and they form the silver chloride precipitate, as you see forming here in the bottom. And then the rest of the ions just are floating around, right? And so these other ions here, these are our spectator ions, we call spectator ions. So you see, you have sodium ions and nitrate ions. There's our spectator ions. Okay. And as those chloride ions fall down with that silver ion attached, right, we have our precipitate is silver chloride. Okay. So if we go back here, so our net ionic equation is going to show this, right? It's going to show that our silver ions, right, combined with our chloride ions, silver ion combined with the chloride ion, and form silver chloride. That's what our net ionic shows. So our silver ion reacting with our chloride ion to form our silver chloride. And that's our solid. These guys here are what we call aqueous because they are dissolved in the water. Right, so that's our net ionic equation. Again, our precipitate was the silver chloride. And our spectator ions, we can see them floating around here, are our sodium and our nitrate ions. Right, so our sodium ions and our nitrate ions are our spectators. They are just watching the precipitate form. Okay. So let's look at another example. Potassium sulfate and lead 2 nitrate. So again, we need to use our charges. Potassium's +1, sulfate's -2, so we get K2SO4, plus lead 2 nitrate. Lead is +2, nitrate is -1, and so we get PbNO3 2. Again, our metals are going to trade partners, so potassium is going to combine with nitrate, and again, we use our charges. Since potassium is +1 and nitrate is -1, we do not need subscripts. All right, and then our lead combines with our sulfate, right? And we get our charges for lead. Lead was +2, sulfate was -2, and again, those equal 0, so we don't need any subscripts. But we do have to balance. Since we have 2 potassiums, we have to multiply KNO3 by 2. That gives us 2 nitrates, but that's all right because we have 2 there. Right? And 1 lead, 1 lead, 1 sulfate, 1 sulfate. And now this is balanced. Right? So now our net ionic equation. So let's have a look at the simulation for a second. Reset. Right? We have some lead nitrate ions. Right? And some, I forgot already, potassium sulfate ions. Here we go. And as our lead bounces around into our sulfate ions, we see precipitate happens, right? Because lead sulfate is insoluble. So again, the net ionic equation are those lead ions coming in contact, right, with our sulfate ions and forming that solid, right? So we're going to write that our lead ions, Pb plus 2, and our sulfate ions, SO4 minus 2, they come together to form our lead sulfate. And again, lead sulfate is a precipitate, so that is solid. Our ions are dissolved in water, and so they are aqueous. Right? Our precipitate, of course, then is our lead sulfate. And then our spectator ions, right? Our spectator ions, the ones that are not involved in the precipitate, right? So our nitrate ions and our potassium ions. Right? All right, let's do one more together. We have calcium nitrate and sodium carbonate. So calcium is in group 2, it's plus 2. Nitrate's minus 1. So we get CaNO3, 2. And then we have sodium carbonate. Sodium is in group 1, so that's plus 1. Carbonate is minus 2, so we'll have Na2CO3. So then our metals are going to trade partners. Calcium's going to combine with carbonate. Again, calcium was plus 2, right? And then carbonate was minus 2. So those equal 0, so I don't need any subscripts. And then my sodium is going to combine with the nitrate. And again, I use my charges. Since sodium was plus 1 and nitrate was minus 1, that equals to 0. Okay. Then we have to balance. So we have 2 sodiums, so I have to multiply over here by 2. That gives me 2 nitrates, but I have 2. 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. All right, so let's put these in our simulation, see what happens. All right, so we have our calcium nitrate and our sodium carbonate. And we see that when the calcium interacts then with the carbonate, right, it forms that precipitate, right? So as calcium ions float around and hit that carbonate ion, they form that precipitate. So that's our net ionic equation. So our calcium ion, which is plus 2, and our carbonate ion, which is minus 2, makes our calcium carbonate. And that's our solid precipitate. And that's these guys are dissolved in water, so they are aqueous. Right? Our precipitate is that calcium carbonate. And our spectator ions, right, are the ones that are just floating around, watching. So sodium and nitrate. Okay. And again, we can determine what our precipitate is from our solubility rules. Remember, if our solubility rules say that it is insoluble, then that equals our precipitate, right? And that's what we write here for our net ionic equation, okay? All right, so let's look at one more. Potassium sulfate and barium nitrate. So again, potassium is plus 1, sulfate is minus 2, so we get K2SO4. And then barium is in group 2, so it's plus 2. Nitrate's minus 1, so we get Ba, and then NO3, 2. Our metals trade places, so potassium's going to then combine with nitrate. We have to use our charges. Potassium was plus 1, nitrate was minus 1, so those equal 0. Plus barium and sulfate. And again, using our charges, barium was plus 2, sulfate was minus 2. So those add up to 0. And then we have to balance. All right, I have 2 potassium, so I multiply 2 here. That makes 2 nitrates, so I have to multiply 2 there. 1 sulfate, 1 barium, 1 barium. Okay, now, instead of using our simulation, we're going to use our solubility rules, right? That first rule tells us that my nitrates are always soluble, right? So then our other solubility rule is sulfates, right? Sulfates are usually soluble, right? But there are exceptions, and barium is one of those exceptions. And since it's an exception, it makes it a precipitate, so it's not soluble, right? It is insoluble. Okay, so to write our net ionic equation, we'll have our barium sulfate as our solid, right? And it's formed when the barium ions and the sulfate ions interact together. So we'll have our barium plus 2 and our sulfate minus 2. And we have to put those subscripts AQ to show that they are dissolved in water. So then again, our precipitate was our barium sulfate. And our spectator ions are the ones that aren't part of the precipitate, right? Since these are part of the precipitate, then our spectator ions are potassium and nitrate, right? So our potassium and our nitrate, right? All right, so we'll practice this more next time.